My name is Jablan Chitanga. So I'm recording this just to illustrate how to run ANOVA, one-way ANOVA in Excel. I don't know how to pronounce it, as well as in SPSS. So I think you are aware that we run ANOVA when we want to compare at least 3 conditions: treatment conditions, interventions, or groups. So it's similar to t-test, but you can read why are we running ANOVA instead of t-test. I don't want to focus much on that. So I just wrote this fiction. I'm just thinking, okay, should I drink coffee or should I take an apple or should I drink water to improve my concentration level? Just fiction. Don't think this is correct. It's not a study. I wish I can do this kind of a study though. So we have 3 kind of the interventions or conditions. So either we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people who took caffeine and that's coffee and apple. I don't know. I didn't know how to, is it liters or milligrams? I don't know. I just wrote 5. But I remember we should run ANOVA when all the variables, the variable actually, the concentration level have been measured at a continuous level. So that's one of the conditions, the requirements and assumptions, if I can say so. So you as you read, you see that the null hypothesis for ANOVA, one-way ANOVA, is that the population, excuse my writing, they're not different. So that is kind of the null hypothesis. This is the second. Remember, we make use of a sample, but our question is actually, we are interested in understanding the population. That's why I'm writing the population mean. This is actually the population mean. Okay, I think we got that. So the alternative hypothesis, the H almost subscript 1, it means that there is at least a difference between 2 of the population means. Maybe there's a difference, maybe all of them, maybe only this, or maybe only between the second one and the third one, of which maybe apple and water and caffeine, something like that. So, but we do not know, and ANOVA doesn't tell us that. I'll explain a little bit further what we do. As you read as well, you're going to find the word post-hoc test. So we are able to kind of identify which ones, although maybe there's a significant, at least a significant difference between 2 of the 3 conditions, treatments, whatever word that you're using. So we can run the post-hoc test to assess that. So I think get that, let's get into, I don't want this video to be long. So remember, let me just write this. Alternative hypothesis is written like this, just for control. Maybe like this, at least, maybe all of them. So it depends on how you want to understand and read stuff. But anyway, let's leave it like that. What I want to focus on is the analysis. So this is Excel, and I'm hoping and believing that if you've watched my previous videos, you've managed to activate your data analysis toolpack. So that toolpack allows you to run a number of analyses. So here we want to just run ANOVA. So you click on data, like what I've just done here, data analysis. Okay, it's coming up. Not responding, it is going to respond. So I think researchers are interested, even ourselves, we are interested in comparing stuff. Okay, is there a difference between whatever? So that is why ANOVA is a common technique used especially in behavioral science, in psychology, especially when we want to compare interventions. Okay, is therapy, antidepressants, or not doing anything? Among other, even in a community, maybe you want to introduce interventions, but we have a lot of options, but we want to assess, but why are we using the other? Or maybe why is there any difference? with all the options that you may have. So that is why we use ANOVA. So you see, if you scroll like this, there are a lot of techniques that we, but we need ANOVA for single factor, means that we have one independent variable. The independent variable is type of a drink. Yes. Can I say choice? Type. Okay. And the dependent variable here is the concentration level. So click on OK. I have another video actually that I did, I think 2-3 years ago. You can check on that as well. So what did I explain? You click and drag down, you select like this, and then you select labels in the first row because I have included the names of the drinks, whatever that you may want. Is apple a drink? Let's call it a drink for now. Maybe these are, I don't know how many, the liters or something, but let's ignore that for now. Then the alpha level is 0.05. I want to explain that for now, hypothesis. And you click on OK. It's coming up. Before I proceed, I like to right click and round off to 2 decimal places. You can do that as well, format cells. Number in this 2 here, decimal places, and okay, 2 decimal places. Okay, at least let me just check these a little bit to make it a little bit neat. Is neat an English word? I don't think so. Let me just, I don't know why Excel leaves a space here. I don't know. I always like to delete this so that it makes a little bit sense like this. So you get 2 kind of tables. So this is an output. You can copy and paste on whatever Microsoft Word document of yours. You can copy the whole thing and paste there. Let's say you're writing assessment. So you can copy, right click, copy and paste. But I want to focus on just how do you interpret what do you understand by this? What is important? Actually, the only thing that is important here is to check if there is a significant difference. So this significance, it means there's a significant difference between at least 2 of the groups or conditions. So there's a difference at least between, maybe we don't know. ANOVA doesn't tell us that. Maybe between drinking coffee and an apple and water, or water and apple only, or maybe coffee and apple only, or maybe water and apple only. It doesn't tell us. So that is why we proceed with post-hoc tests. So there's Turkey HSD that you can run to assess that. And there's another one, I don't know how to pronounce the word. I think it's SCHE, something like that with a double F. I don't know how to pronounce it. I don't want to say it even. I think it's SCHE-F. That E with kind of, okay, let's leave it there. But the most common that is used is Turkey HSD. So that is used a lot. I don't know why. You can read around it. I think I know, but I don't want to focus on that. So this is what we're interested in actually. So is there at least a significant difference between maybe 2 of the conditions or of the choices of taking water or coffee or an apple? So this is what we need only. So yeah, but now like what I've just said, this doesn't tell us much, but that's when and how we may need to proceed and calculate that Turkey HSD. If you are doing, you can do it manually. So the formula is actually, excuse my writing, it's Q MS within, we have that MS within this one. Okay, divided by N, the number of participants in the study. You can check on that N, what we're talking about. And then in the last pages of your textbook, there is a distribution table. I think studentized, whatever T at the back of your textbook. You can check this Q, and then you can substitute the values that we have and then get a score. For example, let's say when you are done, we get a score of 3. I'm just saying 3.00. So this value of figure tells us that the difference between this is the mean actually. If there's a difference of at least 3 between the conditions or the interventions, that difference is significant. But if it is less than that, that difference is not. So that's what this tells us. Okay. So for example, 3 point, let's subtract caffeine. Is it caffeine? Caffeine, how to pronounce it? Caffeine and apple. If we subtract the 2, the 1, there's 3.10 difference. So meaning these two, they are significantly different, caffeine and water. But if we subtract 6.9, 3.8, no, 6.9 and 4.5, it's not more than 3.00. So it's not significantly different. Even if we subtract apple and water as well, it's actually less. It's 0.70. So it's not significant. So the only significant difference is between caffeine and water. Okay, I think you know what to do, and you read around the assumptions that are required for ANOVA, the homogeneity of variance, the Levin test, and the Welsh. I'm going to show you now in the SPSS. So I don't know yet how to do that in Excel. Maybe there's a way, maybe I'm just lazy. But I think what I've just explained now gives you at least, but what about some people asking, but how do we know if there's no significant? Let's say this is 0.52. So it means this is greater than 0.05 is the p-value. So that is when and how we say there is no significant kind of difference between the conditions. So it actually means that the t-crit is 3.5. That's what it means if you want to do it kind of a sketch visual. So this is the f-crit. So any value that is greater than that f-crit, like now we have 11 points somewhere here. It's in the unlikely extreme. So that's why we reject the hypothesis and conclude otherwise. But if this is 0.52, it means actually this f, maybe it is 2.7, I'm just saying. So it's somewhere here. So we fail to reject the hypothesis. It is in the unlikely extreme. That's what it means. You can read around it if you read hypothesis. Okay, I hope this one. So I'm going to show you the other one, SPSS. Quite advanced. I'm just showing you, maybe some of you don't have SPSS. I have it. So I'm just showing you for explanation purposes. But this one you can download, and you can actually activate the analysis toolkit, and anyone can run it. So that is ANOVA in Excel. So I'm going to show you the one in SPSS. Let me just pause a little bit. Okay, so SPSS, what does it stand for? Statistical Package for Social Sciences, yes, IBM. So I've entered the scores, but the way that we enter is a little bit differently. I don't want to focus on that for now. And what you should check though before you proceed is if the scale is actually ratio interval. So that's continuous at a continuous level. You see concentration is actually at a scale. And then the type of a drink is nominal because the name of a caffeine, apple, and so you must check on that. I even added the values for, so let's say there's a questionnaire, you send it out to people, you ask them to choose caffeine, apple, water. So you can allocate the scores for such. So when you get your data, it is usually in scores like this. So I've just added to say 1 is for caffeine, apple, and whatever. I think you get that. So this is our data. It's similar, exactly like what we have Excel. So this is what we have. So these are the ones for caffeine, the 2s are for apple, the 3s for water. I actually have water today and apple and coffee. I want to see what happens. I'm going to drink all of them. So you click on analyze, and remember, I want to compare. So you click on compare the means, one way ANOVA. Do a search. I've selected already. Actually, let me put them back. It's just memorizing. I didn't want to waste your time. So when you get into this kind of selection table option, so the dependent variable, remember I told you that the dependent variable is the concentration, and it is depending on that factor, which is the independent variable. And if you want to include the effect size, did I calculate the effect size for you? No, I did not. I forgot. I'm going to do it for you. So it is important that we also calculate the effect size in ANOVA just to check the variance accounted for by the independent variables on the dependent variable. So the drinking of the choice of a drink towards the concentration, what the amount of variance being accounted for. If you can do a search, it is standard. When you have a significant difference, you proceed to do a search. And it's almost like multiple regression, the way that we do it. I'm going to show you when I'm done with this. But in SPSS, it can be done for you. You select estimate effect size for overall test, and then let's just check what's there. We don't need this one. I don't know what is this even, but we need post hoc. We want to test if there is at least, let's say there's a significant difference. We want to assess where is the difference then. Let me select the turkey for now on one. This is the other one that I was talking about. Okay, let us select it. We are assuming there's equal variance here, as I'm going to show you what we mean the Levin test. But if there's an equal variance, we can select the Danet's one. Let's leave it for now. This stage is not important. Let me continue. And let's go for options. These were not selected. I didn't want to waste your time. So I want the descriptives. I want to test for homogeneity of variance. So the variance actually similar, coming from the same place in the population. I want to test that, because when that is a problem, our ANOVA is not likely to give a true score. There's type 1 error kind of stuff. And then this actually is testing if there's a difference, the Levin test. The hypothesis that the population and the sample variance are actually kind of the same. That's what it tests. And the brown for share, actually, if this is not, if this is significant, we proceed to check for the brown. I don't know how to pronounce it. I don't know what language is it. And then but the most common one is the Welsh test. I think the rest you can read. Please, you can do a search and then click on OK. And let's see what comes up. Oh, I wanted this video to be not to be long like this, but I'm trying to explain. Okay, it's taking long. You can see this is the same table that we had. It's same as this one. There's this, but just a little bit expanded. Where's this now? Coming slow. And then this is a test of homogeneity of variance. This kind of an F test. You can read is even around it. So what we expect is that this is not significant. That is the only kind of aspect in statistics when you don't expect for significance. So you can proceed confidently when the Levin test is not significant. So here it's greater than 0.05. So it's 0.121. You can read around it, go and read around it. But when this is significant, you can proceed to check on on the Welsh test to check if there's equality of means. Are the means not very far away from each other? So when that happens, it means our ANOVA test is not being effective as it is assessing the variability within and between the groups. So we can read around it. But what is important, though, remember we have this, we had this even in Excel. So we're just checking on if this is significant. Okay. So it is it? Meaning that there's at least a significant difference between two of the three conditions. Is it correct English? I don't know. I didn't listen to what I was talking about here. But now the advantage of SPSS, it can assess that post hoc, like what we did manually. I tried to show you that equation. So what do you check here? So this is Turkey HSD, and this is this, I don't know how to pronounce, I think it's German word. So you check on the significance. So caffeine and apple, so here it's saying that it's supposed to have a difference of 3 point, the difference is 3.1. Yes, this is the difference between caffeine and apple. And is that difference significant? Yes, it is, because it's less than 0.05. And then caffeine and water, it's saying significant here because it's 0.04, of which is less than 0.05. So the caffeine and apple and caffeine and water, both they are. This one is the same, apple and caffeine is the same values, but you see apple and water, the difference is actually 0.7, like what we've just calculated there. And it's been said that that difference is not significant. It's 0.558. So it's not significant. So, but the rest, the other two are significant, and then only that one is not. Most of these figures are actually the same. But when you calculate now the, I don't know how to pronounce it, is it chef or something like that? It's also less than, they're all significant here. And apple and water are not significant. So these scores actually are the same. Some people ask me, why do we, and when do we use the confidence intervals? Sometimes we check as well if between the two, the lower bound and the upper bound, in that range, if it passes through a 0, it means that relationship or difference is not significant as well. That's how we make use of that. But let's not dwell on that. So that's what that is ANOVA. I hope, and I decided to record this. Maybe if it comes from a voice that is familiar, maybe you understand a little bit differently. But there are a lot of videos out there, a lot of people. So I just decided to be brave and explain. But I'm not scripted, and I'm not scripting myself. I'm just explaining from the way that I think anyone who is doing ANOVA will understand. But now, also the effect size, the eta squared you see here, we check on this, the eta squared. I don't know what are these. I'll read when I have time, maybe in December. So we check on the 0.464. So this is the eta squared 0.464. What it means is that if you multiply by 100, so there's 46.4 variance accounted for by the independent variables on dependent variable. But now in APA format, just explaining like it as it is. So it's kind of an N with a square like this. What is it? I don't know why I don't know what's that. Like this. This is the effect size. I think you've seen that a lot. Those who are doing systematic reviews, you see that there's a report of this a lot. What is it again? 4.62. So this is it's given in SPS, but in Excel, it's not, you don't get that. Let me just show you how it is calculated. And then we're done. I don't want this to be boring. What do I want to do here? Okay. So in SPSS, you have to calculate it on your own. So the formula for that is SS between sorry, my writing, you have to forgive me, divided by SS total. Sorry. So the SS between is 52.87 and our SS total is 113.87. So 52.87. Oh, I'm writing again, but at least I'm explaining, is it? I'm left-handed, but I use my right hand to move my cursor. I think that's why my mind is trying to fight itself. Like, what's this? Why are you using your right hand, but you always use your other hand? I think that's what is happening. I don't know. Someone can do a study on me on that. See, if you do it, so you get the same. Like what is being, what is, what we get here. Where is it again? This one. Okay, I think you got it. Go and read the Welsh. What does it tell us? And the Brown Force Tay. I think that's how I pronounce, guys. Excuse me, I'm sure now. That's not an excuse though, but I'm just saying. And the Levin test, and what else? That's what we need on. So, but what is important, what you jump onto first is to check for significance. And then when there's that significance, you go and check for, you can calculate the effect size, okay? And then now you want to check which ones are actually different, which conditions or whatever groups are actually different. That's why you check with taking HST. You can do it manually, and you can, if you do it in Excel, in SPSS, sorry, you can check here which ones are significant, which one are not. And I've just explained. So yeah, I wish you all the best. You can go and check on this as well. But for now, I just want you to know how to run the analysis in Excel and SPSS and interpret the tables that are very important. So yeah, thank you. I will try to do another. I don't know which video must I do. Sometimes I do when I'm waiting for food, when people are kind of delaying at home. So that's when I like, okay, let me do this video. And I create some scores. Some scores don't make sense even, but I do apologize for that. But I think I've managed to just explain. I think we have a better understanding, or maybe a different understanding. And that was the purpose of this recording. Thank you.